For the following function, y is equal to e to the power of x multiplied by cos of x, we are asked to find how many local extrema will occur in the domain of x between 0 and 2 pi. So we know that local extremas occur when y prime is equal to 0. So let's differentiate this using the power rule. E to the x cos of x plus, I'm going to leave the plus out for now, e to the x times the derivative of cos of x, which is negative sine of x. So I'm going to put the negative there. I'm going to set that to 0 and solve for values of x that will satisfy this equation. Factor out e to the x and we get cos of x minus sine of x is equal to 0. This expression is equal to 0 when either that first part is equal to 0 or the second part is equal to 0. Obviously, e to the x can never be 0. We know that by the graph of e to the x. It never reaches 0. So that cannot be equal to 0. Let's see if the second part can be equal to 0. So this expression is equal to 0 when cos of x is equal to sine of x. Divide both sides by sine of x or cos of x and you get tangent of x is equal to 1. Okay, so when is tangent of x equal to 1 in the tangent graph? In between 2 pi and 0. Okay, so tangent of x, I'm going to draw some asymptotes here. Something like that. And tangent of x looks like this, right? Okay, so I'm going to label some points. There's pi, there's 2 pi, and the asymptotes occur at pi over 2 and 3 pi over 2, and it's equal to 1. The first point is pi over 4, and the second point at which is equal to 1 will be 5 pi over 4. Okay. So when x is equal to pi over 4 or when x is equal to 5 pi over 4, a local extrema will occur for the initial function of y. So to answer the question, how many local extrema are there? There are 2 local extrema. So in part B, we are asked how do the coordinates of the local extrema in part A compare with those of y is equal to cos of x. Okay. So first and foremost, let's find the coordinates of the local extrema of part A. Okay. So the y coordinate, or y of pi over 4, okay, because we saw in part A that the local extrema for our function e to the x times cos of x occurs when x is equal to either pi over 4 or 5 pi over 4. So y at pi over 4 will be e to the power of pi over 4 times cos of pi over 4, which is 1 over root 2. So this is e to the power over 4 multiplied by 1 over root 2. And y evaluated at 5 pi over 4 is equal to e to the power of pi over 4 times cos of 5 pi over 4. Cosine, this angle here is in the third quadrant. Okay, so it'll take a negative value. And it'll be 1 over root 2 as well, or negative 1 over root 2. Now the question is asking, okay, so the coordinates of the 2 local extrema are, let's write them here, pi over 4 comma e to the pi over 4 divided by root 2, and pi over 4, or rather 5 pi over 4 comma negative e to the pi over 4 divided by root 2. Okay. Now let's see what the values of cos of x are for pi over 4. We know that that's cos of pi over 4, or simply 1 over root 2, and y of pi over 4 is equal to cos of 5 pi over 4, which is negative 1 over root 2. Okay. So how do we compare, or how do they compare? I'm just going to add the 5 here, forgot it. Okay. Well, the y coordinates, okay, are similar to, so what I'm comparing here is this value versus this value, and this value versus this value. As you can see, the y coordinate for our function e of x times cos of x are scaled by this constant here, right? Okay, the rest is the same. 1 over root 2 and negative 1 over root 2 is the same for the y values of cos of x. Okay. So this here scaling is the difference between this guy and this guy.